In 1990, a personal computer had a processor speed of 16 megahertz. In 1999, a personal computer had a processor speed of 600 megahertz. Based on these values, the speed of a processor increased at an average rate of 44% per year. In Part A, estimate the processor speed of a computer in 1994. How does this compare with actual processor speeds of 66 megahertz in that year? We can use the exponential form y equals a times b raised to the power of t over p to answer this question. First, we'll determine the growth rate. We know the growth rate is 44% per year. When we have an increasing percent, we add it to 1. The b value for this question is 1 plus 0.44 equals 1.44. The function is s of t equals 16 times 1.44 raised to the power of t over 1, where s represents the processor speed and t is the time in years. Plug in t equals 4 to find the processor speed in 1994. This returns a result of 69. The processor speed predicted by the formula, 69 MHz, is close to the actual value of 66 MHz. In Part B, a computer that cost $2,500 in 1990 depreciated at a rate of 30% per year. How much was the computer worth 4 years after it was purchased? We can use the exponential form y equals a times b raised to the power of t over p to answer this question. First, we'll determine the depreciation rate. We know the depreciation rate is 30% per year. When we have a decreasing percent, we subtract it from 1. The b value for this question is 1 minus 0.30 equals 0.70. The function is c of t equals 2500 times 0.70 raised to the power of t over 1, where c represents the cost of the computer and t is the time in years. Plug in t equals 4 to find the computer's value in 1994. This returns a result of 600. The value of the computer in 1994 was approximately $600.